I would like to welcome you in this new chapter where we're going to be learning about polymorphism. And polymorphism is the setup we can do in our C++ programs to use a base pointer and manage derived objects. Suppose we have an inheritance hierarchy like we have here. We have shape as our base class, and we can inherit from oval and create a circle class. Imagine that we can create all kinds of crazy shapes that inherit from shape in our C++ program. For example, we have a rectangle class, we have a triangle class, we have all kinds of crazy shapes. Now, if we have this inheritance hierarchy, here is something we might want to do. We might want to set up a base pointer that is managing a derived object and set up code like this. For example, we say shape pointer, and I set up a pointer variable here and use this pointer to manage a circle object that we dynamically allocate for on this line here. We can also do a shape pointer that is managing a rectangle. We can set up a shape pointer that is managing an oval object. We can really set up a base pointer that is managing any kind of object we support in our inheritance hierarchy. Now, some of you are going to ask a few questions. One of them is going to be, is this even legal C++ syntax? And the answer is yes, because if circle is inheriting somehow from shape, a circle is really a shape. And if rectangle is inheriting from shape, it is a shape. And if we try to assign a circle to a shape, we're going to see that that's going to work. So this is valid C++ syntax. And we can do the same thing using references as we see here. We can set up a reference that is going to be managing a circle object that we have through circle 1. We can set up a reference to manage a rectangle that we have in shape 2. We can set up a reference to manage an oval object. We can really do all these things. Now, some of you are asking, why would we want to do something like this? Now, try and think about your inheritance hierarchy here and try to think about what if you want to draw this kind of shape, for example. If you didn't use polymorphism, you would need to set up all kinds of crazy methods to draw each kind of object. And we have no way around this because these are different types. If you have a method that takes an oval and you pass in a circle, that's going to give you a compiler error. But with polymorphism, we can set up a single method which takes a shape pointer or a shape reference, and we can pass in all kinds of crazy objects whose class derive from shape. So for example, we can pass in the address of the circle, and this function is going to draw a circle. We can pass in the address of a rectangle. This is going to draw a rectangle. We can pass in the address of an oval, and this is going to draw an oval. Hopefully you can see how this is useful. We can even do this using references. So if we pass in a rectangle, this is going to draw a rectangle. If we pass in a circle, this is going to draw a circle. You get the idea. This is one of the benefits of using polymorphism. Again, polymorphism is about using base class pointers or references to manage derived objects in our inheritance hierarchies. Another benefit of polymorphism is to allow us to be able to store different kinds of objects in a single collection. Remember, an array can't store objects of different types. If you set up an int array and try to store in a string or a double, you're going to get a compiler error because that's not allowed. So if you have an array that is going to store circles, you can't put in an oval, you can't put in a rectangle, you can't put in a star. You can't really do that because an array by design is going to store objects of the same type. But we can avoid this limitation using polymorphism. Again, we can set up an array that is going to store base class pointers, and we can store in all kinds of crazy objects whose class derive from this base class here. So here we can store in a circle object, we can store in an oval, we can store in any kind of object that is part of our inheritance hierarchy with the base class as shape, and this is going to work, and this is going to be using polymorphism. For example, if you look through this collection calling the draw method, for the first element, this is going to call the draw method on the circle. For the second element, we're going to call the draw method on an oval, and this is going to be really cool. This is something we can achieve with polymorphism. And I want to back up a little bit and talk about what is really meant by polymorphism. Polymorphism really means multiple forms. And in my opinion, what this means is that the base class pointer or base class reference can take multiple forms. At one point, it might be managing a circle. At one point, it might be managing a rectangle. At one point, it might be managing a novel object. So it is a base pointer, but it can take multiple forms because it can be managing multiple kinds of objects whose class are part of our inheritance hierarchy. This is what we mean by polymorphism. So again, the idea is that we can use a base class pointer or reference to manage all kinds of crazy objects in our program. And this is going to have many benefits as we are about to experience in this chapter here. I am really excited to be explaining this to you. This is one of the most powerful features in C++. We are going to start in the next lecture and show you that you don't get polymorphism by default in C++, and what you get is static binding. Go ahead and finish up here and meet me there.